quick recap. We started with the pentagon and established important angle measures, then proceeded to the star. From that, we split off this isosceles triangle and used a ratio of similar triangles to find an important quantity called phi. In short, that means if my pentagon has side lengths of 1, 1, 1, 1, 1, 1, this length here will be approximately 1.618. In short, that's what we mean. Now, let's go back to our other isosceles triangle and apply the same method of similar triangles. So here, we'll be splitting off from this point here. I've split off this triangle from here to here to here to here. That becomes this equals that plus that. We see they're similar triangles. They've got the same 36-degree angle here at the point. There's a couple different ways we can do this. Just so I don't confuse you, here I've defined the side length of the pentagon to be 1. Well, now we're going to define this length as 1. So from here to here is 1, which means this is also 1, which means 1, 1. And this length is the same. Since I used x in that example, I'm going to introduce y as this quantity. Same concept. I compare the ratios, long over short. So in this case, the long side is 1 plus y divided by 1 is equal to, long side is 1, short side is y. Cross multiply, what do I get? Y plus y squared is equal to 1. I can rewrite that. Y squared plus y minus 1 is equal to 0. By plugging the coefficients into the quadratic formula, I solve for y equals -1 plus or minus square root of 5 divided by 2. If I were to punch this into my calculator, I would get 0.618 and -1.618, approximately. Notice the similarity between these numbers and these ones. The only difference is a minus sign. Well, what else is different? Positive, negative, negative, positive, positive, negative. So there's a difference of sign. That's affecting our difference in sign in the solution. So basically this is 1 over 5. Okay, lovely. So how does that relate to our original question? Well, going back to this guy, slapping it there, 36 degrees. If the length of this side is 1, the length of this side is 1, that means this length is x from here to here. If I chop it in 2, that means the length is now x over 2. And splitting the isosceles triangle in 2 leaves me with a right triangle. Therefore, I can define cosine of 36 degrees. Cosine is adjacent over hypotenuse equals x over 2. Well, x, we said, is equal to phi. So that's phi over 2. Well, that's going to be 1/2. What is phi? 1 plus the square root of 5 divided by 2. Multiplying fractions, 1 times the top leaves it unchanged. 2 times 2 is 4. 1 plus root 5 over 4. If I punched this into my calculator, that would be approximately equal to 0.809. Half of this. Because the sine of 90 degrees minus theta is equal to cosine theta, this is also equal to the sine of 54 degrees. We can do the same thing with this triangle. So here we said this triangle has angles of 72 degrees here and here. So pulling from this, if the length of this side is 1, then that means the length from here to here is equal to y. Well, again, if I split this in half, I've now formed 2 right triangles. And instead of y, I have y over 2. So cosine is adjacent over hypotenuse. So cosine of 72 degrees is equal to y over 2. Well, y is equal to 1 over phi. So that's 1/2 times 1 over phi, which is 1 over 2 phi. Well, that's this guy. 1 over phi is this guy. So that's going to be 1/2 times -1 plus root 5 divided by 2. 1 times the top remains unchanged. -1 plus root 5. 2 times 2 is 4. If I plug this into my calculator, I would get approximately 0.309. Notice, if I subtract this from this, is equal to exactly 1/2. To see y, subtract the exact representation, and you'll get the fraction. Because of this property, cosine of 72 degrees is the same as the sine of 18 degrees. 36 divided by 2 means this is 18 degrees. Sine is opposite over hypotenuse. We have the same ratio. So remember these guys and these guys. We've established the exact value for cosine of 36 degrees and cosine of 72 degrees, starting with the pentagon and using similar triangles to find that value. Along the way, we discovered a special number called phi. Stick around. Next time, we will use the trig identities to find cosine of 18 degrees and cosine of 54 degrees. Thank you for watching. I'll see you then.